Hello, I'm Carlos Rosa Suarez, and this is the CRS channel. We're going to continue with our physics problems in kinematics. Before continuing to problem 8, there's something of problem 7 that I want to go back to. Here I went through this too hastily. Here we have the condition in which this term within the radical was 0. So we had v2 minus v1 squared equal to 2ad. And then v2 minus v1 equal the square root of 2ad. And then I had that for such case, the time of collision would be equal to v2 minus v1 over a, which would be equal to the square root of 2d over a. In this part, that time gave me 63.245 seconds. If this were the case, and assuming that the train 1 kept its speed of 15 meters per second, and then assuming trying to find what would be the corresponding value for the speed of train 2, that speed would have to be 21.325 meters per second. That is slower than this value. Okay, this means that the speed of train 2 is faster, and so we have the case in which v2 minus v1 squared would be greater than 2ad. Okay, this means that the deceleration produced by the brakes is too low, and one extra exercise you, the viewer, could try to work on would be trying to find out what negative acceleration or what deceleration would have to be the corresponding one when when the brakes would be applied, so that the minimum acceleration needed so that train 2 would not collide with train 1. And observe on the plots for x2 and x1 what changes would be seen when observe whether or not there would be intersection of the line corresponding to x1 with the parabola corresponding to x2. Observe which would be the limiting case in which the line would intersect with the parabola. So I leave that to you as an exercise. Okay, so now let's start with problem 8. Problem 8, we are given this type of acceleration to a moving particle. We have 5 intervals of time from 0 to 40 seconds. We have interval 1 from 0 to 5 seconds. The acceleration is 2 meters per second over a second squared. The acceleration for interval 2 from 5 to 15 seconds is 0 meters over a second squared. For interval 3, The acceleration is minus 2 meters over second squared from 15 to 25 seconds. For interval 4, from 25 to 35 seconds, the acceleration is 0 meters per second squared. And for interval 5, from 35 to 40 seconds, the acceleration is 2 meters per second squared. So here we have to find the velocity for that particle and the position for that particle. So the initial velocity of the object is 0 meters per second, and its initial position is 0 meters. So from this given data, we have to obtain the body's velocity. So we do that by integration of the acceleration. So speed at any the velocity at any given time t2 is equal to the velocity of the object or the body of the particle at time t1 plus the integral from t1 to t2 of the acceleration. Here we do that numerically, and since the acceleration is constant for each one of the intervals, we can simply do that by adding the areas of the rectangles for each of the time intervals, so that I have for v t1, I have v t1, v of t I1 should then be equal to v of ti plus the acceleration for the respective integral times the time difference between the endpoint of the time interval and the starting point of the time interval. Okay, so we do these calculations and we obtain the following graph for the velocity, which is this one. Yeah, for the interval 1 from 0 to 5 seconds, we have this line that goes from 0, 0 to 5, 10. That is 0 seconds, 0 meters per second. Here we have 5 seconds and 10 meters per second. For interval 2, since the acceleration is 0 meters per second squared, we have that this velocity is constant and remains at 10 meters per second from 5 seconds to 15 seconds. For interval 3, again, the acceleration is minus 2, so we have a decreasing velocity. Velocity starts at 10 at 10 meters per second at 5 and 15 seconds and ends at minus 10 meters per second at 25 seconds. For interval 4, again the acceleration is 0 and then the velocity remains constant at minus 10 meters per second from 25 seconds to 35 seconds. And for interval 4, again the acceleration changes and is constant and remains at 2 meters per second squared from 35 to 40 seconds, so that the velocity increases from minus 10 meters per second to 0 meters per second. Okay, now having obtained the velocity for the body, the particle, the object, we now proceed to obtain the position. So the position at any time t2 is equal to the position at time t1 plus the integral from t1 to t2 of the velocity and the increment of time. So that we are going to do numerically. So that we will do by obtaining the areas below the curve of velocity. Here we have a triangle, here we have a square, here we have another triangle, here we have, triangle, a rectangle, a triangle, a rectangle, and another triangle. So we obtained the areas of the triangle, the rectangle, the triangle, rectangle, and triangle. To obtain the values for the position corresponding to each one of the intervals. That for these parts, that is easier to be done following the method of obtaining the areas for trapezoids. For the trapezoid, okay, we're going to continue this problem in the next video.